So as was stated, I'll be covering the 3DEXPERIENCE R2021x simulation portfolio. Typically, explanations of what is new in a particular simulation software release often includes a dry list of new software features, very much like describing the aspects of an individual gear. This one is red, it has this many teeth, this one is yellow, and so forth and so on. A more appropriate and useful way to describe these would be to convey how all of these gears work together to connect and achieve an overall objective. Each gear may be important, but the most value is when they work together. Over the next hour or so, we will be giving an overview of what's new in R2021x, of the 3DEXPERIENCE platform, and what can be done with it. My name is Joe Canna, as was mentioned. I'm on a team responsible for industry portfolio for Smulia, and among other things, that the messaging around industry processes and roles is properly defined and well communicated. I won't be the only one speaking today, though. You'll hear from Christina about the packaging changes associated with simulation process and data management. Asif will be illustrating an industry workflow involving an excavator, and Ryan will cover simulation-driven design workflows with 3DEXPERIENCE Works. These are the main sections that will be covered. The software enhancement section has a lot of details. The somewhat drier list of new capabilities I mentioned, flavored with the value they provide. As we only have 1 hour, I will not go into details of each new capability. A reference will be made to some illustrated examples from this year's ModSim conference. Then we'll close with where you can find all of these details of each new capability for you to go through at your leisure. Let's quickly go through some of the packaging changes new in 21x. I wanted to give a quick reminder of how the portfolios are constructed. These concepts are not new, but to recap, apps are packaged into roles. Simulation roles are split into two portfolios, the Works portfolio containing 7 roles, and the Industry Roles portfolio containing 29 roles as of 21x FD03. Both portfolios can package any app from across all of Dassault systems. Roles from both portfolios are collected into industry process experiences that are part of the larger industry solution experiences. This is important to know since much of the material made available to you for what is new in a release is given on a per role basis, not really always on a per app basis. For your reference, here's a summary of the simulation roles currently available in 21x. Most of these roles are new, although most of the apps within them are the same as they were in 2020x. The roles are arranged in either industry-specific roles, as seen on the right, or as cross-industry roles in a variety of domains, such as structures, fluids, electromagnetics, and so on, as seen on the left. The intent is that for a given user, only one should be sufficient for them to do all they need to do on the platform, without the need for add-ons. I mentioned there were 7 works roles, which are indicated above. These same 7 roles are also included in the industry portfolio as well. Let's now take a look at the repackaging of what we know as the SPDM.
One of the primary objectives we had during this repackaging project was to better articulate the values we are able to deliver to our customers. Often, when we would have engagements with customers, requests and solutions were described under the umbrella term SPDM, or Simulation Process and Data Management. While it is true that SPDM is a common used term in the industry, using it to describe our solutions undervalues what we can provide our customers through the platform. After many discussions with the field and customers, we found SPDM topics were typically focused on the categories I'm showing here. Our goal is to change the language we use to communicate our value to focus on these categories and the benefits we can deliver as a result. First is simulation data management, where through the platform we provide solutions to manage simulation data across the lifecycle. This data can take many forms, and the simulation domain has some unique needs, but the objective is to organize data, make it accessible, and provide traceability much like any object we manage through the platform. The second category is V+R test governance, to enable customers to define, execute, and monitor validation and verification strategies, often focusing on ensuring compliance with regulations and requirements. Third on the list is simulation process automation. This is an area we have been working with our customers on for many years. Through simulation process automation, our customers can easily deploy best practices and, more importantly, ensure that they are accessible to users and the methodologies are repeatable. By encapsulating knowledge in an automated process, our customers can significantly improve efficiency by eradicating manual tasks. Next is design exploration, which is the process of using studies to evolve and investigate the design space with the intention of enabling discovery, innovation, and ultimately to make the best decisions. Today, our approach for design exploration is primarily by using an automated simulation process combined with a method such as design of experiments or optimization. This approach is quite flexible and valuable for our customers who capture complex processes that may include design exploration. We are progressively moving towards solutions that enable more design exploration with various 3DEXPERIENCE apps to deliver more value to our users. Finally is collaborative decision-making. While this isn't necessarily a category itself, it is recognized that there are often many stakeholders in an organization that contribute to the decision-making process. Enabling our customers to share and visualize their simulation data through the 3D dashboard facilitates collaborative trade-off across potentially conflicting requirements. This slide shows how our roles have evolved to capture these categories. There are many tools on the platform today that aid our customers with managing objects on the platform. Our objective is to work with the platform teams to ensure the needs of the simulation users are addressed. Many customers today are leveraging our Process Composer apps combined with templates to accomplish some of these tasks. These capabilities are still available, but we do not have a specific role focused on delivering this. V+R test governance will be introduced through the Test Manager role, VRP. Simulation Process Automation is delivered through the new Simulation Process Engineer, SPF role. This role includes all of the apps needed to author simulation processes and to create and deploy simulation templates. Design Exploration is delivered through the Multidisciplinary Optimization Engineer role, MDO. This role includes everything in SPF, but also expands simulation processes to enable multidisciplinary design exploration. It also includes a full environment for visual and data analytics, which is a key part of the design exploration workflow. Soon, we will begin to introduce discipline-centric design exploration that will enable studies from within some of our key design and physics roles. The objective is to make it easier and more natural to perform design exploration from within the user's familiar environment. We will provide more information when these new apps are closer to the release date. Finally, collaborative decision-making provides our users with apps that enable them to consume simulation-related data for sharing results and enabling decision-making through trade-off studies, primarily through 3D dashboard. This slide shows how the apps have evolved with the new packaging. Previously, we had two roles: Simulation Foundation, which provided infrastructure and apps focused on activities such as monitoring and sharing data, and the Simulation Process and Optimization role, which added capabilities to author automated or design exploration processes. Additional roles could then be added using these as prerequisites to expand the available capabilities for ad hoc processes, template creation, and data analytics. The new roles are intended to provide all of the apps needed to satisfy the categories I just described, instead of adding capabilities a la carte. For example, for users performing design exploration, they will not purchase separately the ability to post-process their results. As part of this new packaging, there were a couple of key changes that were made. First, Process Composer is now split into two apps: Automation Process Composer, which provides the tools needed to build a process that can automate simulations and process data, and Optimization Process Composer that extends this capability to enable design exploration workflows, including methods such as DOE, Monte Carlo, or optimization. Another notable difference is that the Simulation Collaborator role is no longer an authoring role. Execution of automated or design exploration simulation processes will be performed through the SPF and MDO roles respectively. We also simplified our business model for execution. Automation processes will now consume 1.2 tokens and optimization 2.4 tokens, with additional tokens shown in the table for parallel and batch jobs.
Thank you, Christina. Now let's run through some of the new software enhancements in R21x. Not all the enhancements, like I mentioned before, will be presented, just some that have significant impact on certain roles and workflows. For each of these, only the roles which are significantly impacted are listed, even though other roles may include the app which has the improvement. These enhancements will be presented next in a few different arrangements of the same information for easier future reference. So many items may be repeated. So I'm going to go through some details at the beginning, and then the rest of these sections that have a lot of repetition, I'm going to skip over the repeated content, but it's arranged that way for you to easier reference later. So there's only really one major general improvement that applies to all of the different apps and roles, and that is the cloud enhancements for a robust simulation experience. So for FDO1, the cloud team worked hard to provide huge performance improvements for users submitting jobs on the cloud. These are seen in two areas. When executing a job, up to 2 to 3 times speed up factor for medium to large size models, which are over 1 million nodes. This is thanks to a faster cloud compute infrastructure, leveraging the latest generation of CPUs, along with the added support for distributed parallel computation on the cloud with low latency networking. Then, when visualizing large simulation results stored on the cloud, the visualization startup time, which is the time it takes to see an image after clicking on the results button, has been sped up by up to 5 times, again depending on the size of the results. This is due to an improved cloud architecture minimizing the movement of large simulation results data. In other words, any simulation cloud user out there will experience a dramatic improvement in the time it takes them to run jobs and look at results. In FDO1, only 3DEXPERIENCE users of native structured apps will see the enhancements, but FDO2 extended this implementation to Fluid's native apps. Here we're summarizing the structures apps impacted by the improvement in FDO1, which are mechanical scenario, structural scenario, linear structural scenario, and linear structural validation. And they in turn deliver these benefits to the users of the roles highlighted in blue on the right. Okay, let's look at other app-specific enhancements. We're not going to cover every single function delivered, and we try to provide you with a good sample of what's being done. All the details can be found in the release notes and in information found on the platform, which I will be highlighting later in this presentation. You'll see that throughout the slides, we are showing you what the enhancements are, and on the right, we are again highlighting in blue which roles are seeing the biggest impact from a given set of enhancements. And at the top, whether the enhancements are delivered in GA or in a particular FD. First, for structural model creation, the way we support NASREM data has been improved. This provides an increased incentive for 3DEXPERIENCE adoption, and we're providing users the ability to manage and use legacy and supplier data while maintaining the digital thread promised by the platform. A few examples. Additional data cards are supported. The importer now supports the inclusion of reference files, and we're giving it an option to structure the imported data. We're also enhancing the support for large multi-level assemblies, and in particular, the ability to take substructures into account. And we're now able to generate a meshed assembly in an automated way, instead of the automation generating meshes under each part. This is a huge usability improvement, particularly important when dealing with spot welds. As it regroups all the meshes at the root of the product structure for users to consume, instead of having to travel through the different parts when generating the meshes automatically. Another nice user experience enhancement is the ability to activate and deactivate one or multiple properties and abstractions from the connection manager. This is going to sound bad, but before, the only way to deactivate a connection mesh was to delete them. Not super convenient. Still in the same app, structural model creation, we're improving how virtual bolts are detected. So now, instead of only looking for holes when trying to detect where to create a virtual bolt, we can search for user-defined points and lines. This increased the robustness and speed at which users can define these very useful virtual bolts. We keep improving the surface meshing in many different ways. The mesh quality and regularity are getting better and better, in part driven by the partnerships with strategic customers. And we're adding nice features like the new lined fastener T-joint construct, a new thickness mapping, and new section called shear panel. This last one is particularly important for A&D customers, aerospace and defense, and related to what is being done in legacy codes like NASTR. Overall, these enhancements provide users with the ability to increase how accurate the representation of thin geometries is, and therefore increase the accuracy of the simulation results. In mechanical scenario, still in FD01, we're delivering the ability to use the FKM method to assess the fatigue of welds. This improves the credibility of the 3DEXPERIENCE structures apps as a fatigue solution and provides users the increased flexibility when assessing assembly's durability. Here, in structural scenario, multi-edit for scenario features to allow users to make the same changes to multiple scenario features in one edit operation. Each video on this, during this, well, you're not going to be able to see that. So to make it easier, each one of these slides has a video, but each video on these slides can be seen on a wiki page, which I'm going to give you at the end of this session. For linear scenario, SOLIDWORKS simulation data support is included, SOLIDWORKS Connected, to streamline the engineering workflow with a unique capability. You'll be seeing more about that a little bit later. For post-processing, provide users default global sensors automatically after solve for faster and more efficient trade-off studies. For fluids, and this is our native Navier-Stokes-based solution, the main improvement is on solver performance. This is significant and important because it allows users to get to the results faster. We've improved the solver efficiency when working in parallel to be 10% faster for the segregated solver and 5% faster for the coupled solver. And the way the solver processes input and output data is faster by 30%. For Physics Explorer, a couple of nice improvements. We're providing users with more ways to define cut planes, for example, by using a user-defined axis system. And we're adding the ability to define results sensors on a specific axis. This is actually fairly important. A sensor automatically extracts values for the quantities the user is specifically interested in. This is particularly useful in the context of automation. If you want to reuse the value in a result as an output parameter to monitor, for example. When looking at efforts in a bolt, again, for example, it is often more useful to study what happens along the axis of symmetry of the bolt, rather than at its surface. This new capability allows users to do just that when using sensors. So here, the new results comparison across analysis cases and simulation objects is the new capability. You can compare multiple field and XY plots from the same analysis case or different analysis cases in an intuitive configurable comparison preview pane. Results comparisons tasks become easier as you can display more than one view and more than one plot at a time. The main enhancement for plastic injection is all about non-conformal meshes, which is when the nodes of two surfaces in contact are not aligned. This can sometimes become tricky for the solver to process. So in FD01, we've enhanced the robustness of the solver to deal with these types of configurations. And when it's not enough and the non-conformal meshes need to be fixed, we've added highlighting and fixing tools to help the user to do so. Finally, for the Process Composer and Optimization Process Composer apps you heard about earlier from Christina, we are improving the user experience with a redesigned interface for mapping parameters. This leads to a lot of time gained when defined optimization loops in mapping input to output parameters. And some might say increase user satisfaction when using our product. We're also adding a so-called N2 parameter map, which is very helpful when it comes to understanding the data flow in an automation and optimization loop. By looking at the path and numbers of the parameters as they input and output the different adapters in the loop. So I'll not go through the details again, but the same information that I just showed on a per app basis is shown in this section on a per domain basis. I'll just flash the different sections by so you can see what I mean. So here you see the structures enhancements involving improved user experience and all the roles that are significantly impacted by that. The improved functionality for structures, same thing. Again, just reorganize same information that I already covered. And the fluids enhancements as well. Just so if you want to refer to it in the future on a per app basis versus a per role basis for your convenience. And here are the optimization and automation ones. Now let's switch gears and give you an overview of the R21x FD01 portfolio for Works portfolio. Again, a lot of the same information. I'll talk about a little bit general things associated with the Works portfolio, but then the rest of the enhancements will be summarized in the same fashion. The Works simulation portfolio is part of the 3DEXPERIENCE Works portfolio targeting the mainstream community with design, simulation, manufacturing, governance, and marketing and sales domains. In 2020, the Works simulation portfolio is targeted at top simulation domains, including structures, computational fluid dynamics, plastic injection, and collaborative decision-making, so users get the right technical insights in all required domains at the right time. Works users are able to assess performance, reliability, and safety of their products for a faster and stronger manufacturing and go-to-market phase. With this new portfolio, tailored for the need of the engineering community, users experience unique engineering collaboration on a single and shared cloud environment. They gain a full integration of design and simulation to increase innovation and eliminate silos. With this cloud portfolio, hardware barriers are removed to provide virtual testing benefits to all users through unique cloud computing. The value delivery plan for simulation has been structured along the following 5 drivers. 1, improve structural performance and quality. The structure portfolio provides a wide range of capabilities from a simple linear analysis of a single component up to a complete and complex simulation of the entire assembly with contact, nonlinearities, and dynamic effects with a scalable set of roles. Structural designer, structural engineer, structural performance engineer, and structural mechanics engineer. All of them are based on the market-recognized Abacus solver to offer robustness and accuracy to all users on the same platform, ensuring consistency. Single source of truth for the engineering data and unique user experience for faster adoption. 2, fluid flow and heat transfer with CFD to deliver quality products that run at their optimal performance by designing proper heat dissipation and fluid flow for external or internal flow. You can use Fluid Dynamics Engineer. 3, optimize injection molded part designs. Making injection molds is a very costly operation. Errors can result in a huge cost. Use the plastic injection engineer role to produce molds that will produce flawless parts that your customers will love. 4, facilitate collaborative decision-making across the organization. When designing a new product or improving an existing one, testing its performance across customers and companies' criteria can lead in many different alternatives to assess. The simulation collaborator role helps users to accelerate selection of the best design by comparing performance metrics across design alternatives. In a very intuitive user interface, all web-based, users can rank designs based on requirements using multi-criteria decision-making methods. To make informed decisions, users are empowered in performing trade-offs between competitive objectives and constraints, so the comparison is meaningful and lead to the right alternative selection. Within a 3D dashboard, users can easily visualize simulation data for interactive and collaborative reviews, changing the design process into a collaborative experience. The Works Cloud portfolio has been enhanced through these roles to meet users' day-to-day needs and bring a unique design stimulation to all design engineers. We've already covered the enhancements to these roles in the earlier section, but I'm going to show them in here just again in a structured way for future reference. So you see here they're arranged more toward the SOLIDWORKS user. So I'm just going to blast through these because again we went through much of this material in the previous section. Now, on to the illustrated examples. Asif and Ryan will show you how these improvements affect industry workflows.
Good morning, good afternoon. I'm delighted to have the opportunity to highlight some of the new functionality and capabilities of the 3DEXPERIENCE platform for simulation. The new functionality will be shown in the context of a realistic industrial engineering process based on an excavator model. So let's first have a look at this process. It is to validate the design of an excavator with structural simulations. The CAD model has been built using CATIA application, but it could have come from any third-party CAD system. The structural validation here will be performed with three main simulation types. We will start with a system-level nonlinear static analysis, durability assessment of the part, and finally, we will conclude with static and durability assessment of some of the welds. So for my part of the presentation, I will be using a dashboard, as you can see on my screen. So this is the 3DEXPERIENCE dashboard in a web browser, and I'm going to take you through various workflows. So let's switch over to the assembly level simulation tab. And here you can see that in my dashboard, I have a spiral on the left representing the various pre-processing steps that will be carried out to build the model, basically do the meshing and the section assignment, and then get into more details with connections. So first, let's have a look at the assembly that we will be working with. So I'm going to show you the model in this 3D Play web application. The analyst can quickly review, manipulate the model, and then we can look at the assembly structure. For example, here you can see the top level assemblies. And for this presentation, we're more interested in the front attachments for the boom and the arm. So we can go in and we can review the various components and decide which ones to do the simulation on. But it's actually more interesting to get a high-level overview using some of the tools. For example, in the application, we have an explode option. So when I click on it, it explodes the model to show the first level, top level subassemblies, and I can go in and dig deeper inside to look at subsequent levels of subassemblies. And here you can see all of the subassemblies have been exploded for view and understanding. As I mentioned, in this simulation, we're going to focus on the boom, and I can move these parts to understand the structure. So we have these thin solids, and also we have some of these reinforcements, which are actually made of solid elements. In addition, I can do some measurements if I wanted to, and also, for example, collapse the assembly and maybe enable a view cut to inspect the interior of the model at different locations. So once I'm satisfied with the version of the CAD model, I can go ahead and begin with my finite element simulation definition. So the first step will be to define the mid-surfacing definition and the mesh. And in this case, we're going to use the automatic tools available on the platform as they have been developed in the last few releases, providing a lot of efficiency to the user. So we're going to look at the assembly, and right now we're in the model and assembly design workbench. So we can switch over to the automated FEM section and then begin with the process for defining the mid-surfacing and the mesh. So with this new capability, we have this advanced option for automatically generating the mid-surface mesh. And here we have a bunch of procedures. We can specify some parameters, choose the parts, the mesh size, and the user can also define additional procedures to be used based on various conditions. So some of the parts will be mid-surfaced and meshed, while the remaining few will be meshed with solid elements. And in addition, we can automatically create shell sections and material sections. So here we can see that 30 parts will be meshed and mid-surfaced. And when we hit run, you can see a report where we can now look at the results. Now, obviously, if there was a problem with the mid-surfacing or the mesh, the user can go in and modify some of those parameters using this interface. So we can do a quick review, and using the visualization management tools, we can have a closer inspection of the mesh. So the blue mesh is the shell mesh that has been generated, and then the others are the dead mesh shown in the other colors. So the mesh looks good, and we don't need to revise anything. We were successful in the meshing operation, so now we can go back and proceed with the next modeling operation. So to model the welds in the assembly, we're going to use the line fastener and detection tool. So let's look at that. So as before, we're looking at the meshed boom assembly, and we can go ahead and start with defining the line fasteners to represent the mesh. Now, again, we can look at the parts from the geometry or the mesh. And now we're in the structural model creation app, where we're going to use the line fastener tool to use the weld curves that were defined in the CAD system for the weld creation. So we can select the weld lines shown in blue that we want to use. And you can see that we have 52 entities selected. Then we can use the search tolerance to search for adjacent parts that will be connected by these welds. And as you can see, we have a lot of other parameters that can be specified for the weld definition. In many cases, we can use the defaults, or we can go ahead and hit the search button. So once the search is completed, you can see different welds that have been created. We can highlight, and the associated faces that are connected are also highlighted to facilitate in the review. Next, we can zoom in, and we can see in light gray the new connection meshes that have been generated for the welds with the compatible meshes. And we can visually inspect the different regions to make sure it's correct and complete. And obviously, we can hide certain parts to see the interior, as we can see these stiffening plates. In addition, it's also a good idea to check for interferences, in regions that are not connected. So you can see that most of the weld line regions are shown with blue elements showing connectivity, but these red highlighted elements represent intersections between solids and shells, or solid to solid. And we can obviously define tie constraints manually to connect the remainder of the parts. So once the automatic weld creation has been created, as I mentioned, we need to define additional connector elements for the actuators, maybe create some couplings and other types of connections. And that, again, can also be facilitated through the use of connection templates and automatic instantiation. And a lot of these can be based on best practices that have been defined by methods developers in your organization. In the interest of time, I'm not going to show the remaining steps of this modeling sequence, but I'll also mention that once the connections have been completed, we provide a comprehensive connections review capability with some recent enhancements, for example, to look at all of the connections that are associated with a particular part, or all of the parts that are connected to a particular type of tie constraint. So this helps in quickly reviewing the connections in a tabular format with 3D highlighting. And then finally, some of you may know we have had material calibration capability on the platform for looking at realistic material calibration and parameter definition. We've made several enhancements in this release. For example, we now have the ability to look at rubber test data, which may be frequency-based, and we can do a curve fit on that with the material calibration app to come with appropriate parameters for realistic simulation. So next, we're going to move to system level simulation definition. So again, in the spiral, you can see the various steps that are needed to define the simulation. So let's first have a look at the model plot definition. So here we're going to review the model that may have been created by a different user or maybe in an earlier session. So we are in the model plots workbench, and this allows you to quickly review the definitions in the model without having to run the simulation. So right now we're looking at the connections, and then we can color code by material, for example, to look at the material assignment to make sure it's complete and correct. And then we can also look at other parameters such as the thickness of each of the shell section. One interesting recent enhancement is the ability to look at multiple plots at the same time. So we can activate multiple plots. They can be in the spread mode. We can specify the spread distance. And again, we can simultaneously review the shell thickness and the material assignment for verification. So you can see the legend showing the details for the materials and the shell thickness. Another recent enhancement is the ability to query the mass of the entire structure. So you can see in the table, we have not only the mass, but the central volume and moments of inertia. And you can also pick or filter based on specific parts and look at the mass contribution from specific components. And obviously, we have some convenience tools where you can export this information, and it is also persisted with the simulation. So we're good with the modeling definition. So we can go ahead and do the scenario definition, which is essentially loads and boundary conditions. So we have already created the steps and the loads and boundary conditions, but I'm showing the feature manager, which will be used to review this two-step simulation. So we're assuming a service load where this excavator is doing some kind of a digging with a hard soil, and we're going to review the connector forces. And using this new functionality, we can selectively hide or show specific scenario features such as load and restraints to get a clear picture of what's active and how it's being defined for verification. So you can see the two steps and the service loads that are active in the loading step. So you can see the connector forces. Another nice enhancement that we have delivered in the recent release is to multi-edit scenario features such as connector forces or bolt forces. So you can select multiple rows from the table and be able to specify a new value. And this handles different values which can be updated with the new value. So once we are satisfied with the simulation definition, we can go ahead and execute it. So in the last couple of releases, we've spent a lot of effort to enable high performance compute infrastructure on the cloud. So you can run your simulations very efficiently using the appropriate resources on the cloud for native and imported simulations. And we use that to run the simulation. In the latest release, we've extended the cloud compute capabilities to also include post-processing. So the big advantage here is that we can do post-processing without having to download the bulk data to your local machine, so saving bandwidth and giving high performance. So here we're looking at the results of the FEA nonlinear simulation that we just defined. We can look at the plots of displacement, one mesostress, and we can zoom in and query results in higher granularity. We can see that in this case, the main booms and some of the attached parts are modeled with results, while the bucket and the main body is modeled as rigid. A recent enhancement that I'd like to highlight is the automatic creation of sensors during the solve. So this is available both for designer and expert simulation. And you can see some key quantities such as maximum displacement, principal stress, von Mises stress, and mass have automatically been created and available for review. So this helps, for example, if you're doing a design iteration and you want to look at the change in the value, or maybe a DOE, or in an optimization study. We've also enhanced the ability to create resultant sensors. You have automatically created sensors to look at force and moment. But in addition, you can also manually create resultant force and moment on a view cut. So here we have activated a view cut, and we can drag it, and we can enable the display of the force and moment on that section. The new enhancement is you can now also define force and moment output on a cut surface. So here we can choose the cut surface, that's the current active view cut, and we can look at the force and moment resultant on the view cut. So all of this information is persisted. So if you were to rerun the simulation, these values would be updated based on the new results, and they would be available for review very readily. And obviously, you can define multiple cut sections as well. So in addition, we can run additional analysis cases or simulation types. For example, we can do an ultimate load simulation. For example, here I have a tip limit simulation where we're looking at an extreme case where the bucket may be constrained and the back of the assembly is uplifting, and we can see the more extreme results in this case as well. So you can have multiple analysis cases defined in your simulation. Okay, so that's all for the structural simulations. Next, I'm going to switch over to the next tab of my dashboard, and this is for durability assessment of a single part. And once again, I am showing the different steps in the spiral on the slide on the left, and we can go ahead and look at some of these details. So the first step for the user is to review the results of the FEA simulation. So here we have this connecting bracket with particularly high von Mises stress, and we want to do a study of the durability performance. So you can see the loads that were defined in the finite element analysis. We have three forces representing the service loads, and we're going to use this simulation for defining the durability analysis. So you can see a couple of hotspots that are present in the model. Okay, so now let's look at the steps to define the durability simulation in steps number 2. And here we can look at the part in more detail. So we have in the same simulation a new analysis case with the forces, and we can go ahead and create a new durability case. So we can go to the durability section and define the fatigue loading parameters. Here, as I mentioned, this is the nonlinear simulation, so we can select the steps and the frames to use. We can add frames, so we're going to select all frames from the 2 steps, and then we can define the number of cycles without any failure. And then we can also modify or specify the surface finishing, which is critical as fatigue cracks typically begin from the surface. So using the same interface as previous, we can go ahead and run the durability simulation. So you can see that the exact same UI approach is used for the structural and fatigue simulation. So the simulation has completed, and we can go ahead and look at the results. So when we zoom into this region, we can see 2 hotspots with unsafe design with log of life less than 0. So obviously, we have to address this situation with a design change. Typical design change is, maybe modifying the geometry, maybe removing a fillet or modifying a chamfer. So that's using standard CAD tools. So I'm going to skip that in the interest of time. So we're going to jump right ahead to step number 4, which is the results comparison with the modified design that has been run with the platform. So let's look at the results comparison. So on the right, you can see the modified design, and one of the hotspots has been eliminated with the modification. And the user can obviously go ahead and make further modifications. Now, this comparison tool is also new. It's pretty convenient and easy to use. It's available for standard and durability simulations, so structures and thermal. And you can drag and drop results or plots from different frames, and then you can have a comparison with multiple windows with a lot of synchronization for view manipulation, as shown here, but also for steps and frames and legend. In addition, you can save your comparisons, and also you can compare XY plots with field plots and run animations with synchronization. So that concludes this section where we were looking at durability of a single part. My final set of slides is on weld strength and durability analysis with the FKM method. And again, here we can look at the bucket subassembly that we're going to be analyzing. So we're going to look at the weld strength between the bucket and this bracket, and also between these cylindrical attachments with the mount. So we can go ahead and look at the steps. So typically, when you are dealing with complex CAD simulations, you don't want to disturb the CAD model that has been given to you, because you have a PLM system and the CAD data is master. So we have this new capability where you can create an abstraction shape with geometry simplification that will contain your simplified geometry for finite element simulation. So we can open the bucket part in a new window, and then we can remove or modify some of these fillets or other fine features that's not needed for the fatigue simulation. So here we're using the tools to simplify some of the detailed geometry. So as I mentioned, we have strong links between the abstracted geometry for simulation and the parent. So if the design was updated, those changes would automatically be reflected in this abstracted geometry. So once we're done with the changes, we can go ahead and define our weld simulation. So here we're using the same subassembly, and we are in the FKM analysis case section, and we can go ahead and define the various parameters for FKM-based fatigue assessment for the welds. We can also specify some additional parameters for the welds. In many cases, you can use the defaults, or you can specify some specific handling based on your use case. So we selected the welds that we want to analyze, and we can review the fatigue parameters. So once everything looks good, we can go ahead and define the loading. So in this case, we're using linear perturbation steps. We have 3 service loads shown here, and we can combine them and define the number of cycles with superposition, and also a scale factor to combine the signals. So we're going to do that for the 3 loading cases. And then once that's completed, we can go ahead and run the FKM simulation. I will mention that we're also working on other methods. For example, some of you may be interested or familiar with Verity. That's something that will be made available in coming releases. So once the fatigue simulation with FKM has been completed, we can go ahead and look at the results. So we have first the static simulation results. We're looking at 1 meso stress, and you can see the higher stresses in the welds that we are evaluating. We can switch between the steps representing the different load cases. And then we can look at the utilization for the individual weld bodies that have been analyzed with FKM. And in this case, you can see that for all of the load cases, the utilization factor is less than 1, meaning that the welds are safe for the number of cycles for this simulation usage.
Thanks everybody for attending. I'm happy to be here and wanted to share some of our latest developments that are focused on simulation driven design workflows. So a few years ago, we decided to put more focus on our simulation solution for designers and design engineers. And so we created this dedicated portfolio called 3DEXPERIENCE Works. And this is available on the 3DEXPERIENCE platform on cloud to try to give all the users benefits of early virtual testing to assess product performance. These workflows are being developed to continue to break down the barriers between design and simulation, and we've focused on what we call these three pillars here: connected, scalable, and powerful. So if we dig into these a little more, for connected, we're trying to connect people during the product development process to make them more productive. And the 3DEXPERIENCE platform lets the users collaborate during the design process to help them be more efficient working together and improve the development process. It's a cloud solution where data is secure and accessible to any of the people working on the project. And basically what that's doing is providing a single source of truth for the data. So we're trying to bring the world of design and simulation closer together for a true simulation-driven design experience. And the scalable means we're addressing the needs for virtual testing from the designer to an advanced engineer analyst in a common environment. And what that also enables is that a user can expand their capabilities based on their needs. And since this solution is cloud, it's another way that we can help try to break down hardware barriers. So any company, whatever their size or whatever the IT infrastructure, can benefit from cloud computing. And powerful, so we're delivering simulation solutions powered by the Abacus technology. And powerful also includes making life easier by providing unique capabilities such as general contact. So we'll highlight a few of these here. I have some videos to talk about this. So first with connected, let me go ahead and start this. We'll look at a couple of design workflows. And the first one basically is starting with your design in 3DEXPERIENCE with CATIA design app. So this isn't new in the situation, but it's a little bit of a reminder here. So once you have your data on platform, how easy it is to move from one app to the next. So the data can be consumed by any app, including simulation. So here is just showing a setup of a simple bushing. And we're using the assistant panel here to run the simulation and then take a look at the results. So we're just looking at some strain and a load versus deflection curve. And again, since this data is on platform, it's all being used. Each app is using the same data. So on the left, I have the design CATIA app. On the right is the simulation app. So you can see changing the design instantaneously affects the simulation. So we just increase the size of the voids here, and then we just go ahead and refresh and rerun the simulation. And then we can look at the new results here. And as Asif showed earlier, we do have results comparison tools to quickly pull these results and do a side-by-side comparison in this case. And we can also pull in the force versus deflection curves here and take a look at those as well. So the next workflow is newer, the way we're doing it here with the design to simulation from SOLIDWORKS desktop. So what we have here is SOLIDWORKS connected. And when you have that, the first thing I'm showing here is that now in your SOLIDWORKS desktop, you can apply materials to your parts from the 3DEXPERIENCE platform when you have the SOLIDWORKS connected set up. And so here we just apply the material. And then the next thing, you can also connect the CAD data to the 3DEXPERIENCE platform and make the 3DEXPERIENCE platform basically the master data. And we do this through this PLM services panel, which is like a portal from the SOLIDWORKS desktop to the 3DEXPERIENCE platform. So here we're just going to convert and save the CAD data to the cloud, and this will be our single source of truth. And once the data is on the cloud, on the platform, again, it can be accessed by any app. And in this case, we can directly open up a new simulation from SOLIDWORKS desktop, but it's a simulation on the 3DEXPERIENCE platform. So we just go to the compass and select your simulation tool that you'd like to use. And here we can go ahead and start a new simulation. But another thing that we've included, though, is that if you already have SOLIDWORKS simulation study data set up, at least for a static situations, we can transfer that data as well. So back to our panel here, the SOLIDWORKS connected, you can see we can upload the simulation data into the 3DEXPERIENCE simulation automatically. And here we're just taking a look at what was transferred and what hasn't been. And then you can continue to work on your simulation and go ahead and run it. And then using SOLIDWORKS, so once that data, the master data, is on the 3DEXPERIENCE platform, again, all we need to do to update it is we reserve the data, and then we can update it in SOLIDWORKS. And we're controlling the data through SOLIDWORKS. As soon as we add the update, go ahead and, again, we're going to save and convert and automatically release the data. And then we'll jump back on to the 3DEXPERIENCE platform for the simulation that was already set up. And once we get into the simulation, we just do a global refresh, and that will automatically update our simulation where we can, again, run it. So that's our a quick look at a few features from Connected for the design to simulation. In the next segment here, I'd like to talk about the scalability. So I'm just going to talk about a few things quickly, and I'll go ahead and we can look at this through a video. And the first thing that we'll look at here is the assistant panel that we have available for users. So, anyone can use it. If you're new to the platform, this may be a nice way to get used to it. If you're not using it frequently, the assistant panel is a nice way to set up your analyses. So you can see here, we're just going to kind of work from top to bottom, and we have visual feedback about the simulation setup. So again, you can do pretty much everything through the panel. We've included most of the tools in the assistant panel, but if there's not a tool that's included in the assistant panel, that would be, again, in the action bar at the bottom. So here it's just, we've selected a couple parts from the assembly, applying materials, setting up some connections, and then we're applying the restraints, and then we're going to apply a couple different loads, and then we can just go ahead and simulate it. And basically this entire setup was driven from the assistant panel. And then here's the final results to look at. The next section of scalability here, just a reminder that you can also scale by simplifying some simulations. So in this case, we have an axisymmetric idealization. It's a 3D part, but the loading and the geometry in this case can be axisymmetric. So all we need is a cutting plane and an origin in our line of axisymmetry here, and then we can go ahead and set up this problem as axisymmetric. And the advantage in this type of situation is you can save essentially a magnitude of runtime, probably, or more, running this thing as axisymmetric. So you can really refine the mesh and take a look. So what we have here is just a rubber seal, and we're compressing the seal between the two components. And then when you want to discuss the results with other stakeholders, it's easy to take a look at this like it's 3D as well. So the next feature that to talk about here for scalability, again, there's many features, but I'm just going to highlight a few things. So there's lots of different meshing tools available for all levels of users. We also have some model prep tools available to help with your meshing. In this case, we have a solid can, and we're just going to extract the surface so that we can do a shell mesh on this can, and we're just going to use some quad shell elements. And one of the nice features again here is once we have this mesh set up, since we've extracted the surface from the solid, it automatically is able to pick up the variation of thickness through the solid. And you can see that in this contour plot here. So the center of the can is the thinnest and the ends are getting thicker. There are also hexahedral meshing tools available. A couple different methods to do this, like the sweep mesh. So here's a tube hydroforming simulation that we're setting up. We do the sweep mesh for a couple of the parts, and then for more complicated geometry, there is a partition hex mesher that you can partition geometry into sections that can be hex meshed pretty easily. And finally, under scalability, again, we have cloud execution option available. So when your models are getting large and you don't want to run them locally to take up your machine, we have this option where you can run on cloud. Currently, we have 18, 36, or 144 cores available to run, depending on the size of your model. And then finally, for Powerful, a couple of highlights. I would just like to talk about first. I'm going to play this video again, and we've already seen the situation with this cam lever clamp and this bicycle post, but with general contact, setting up contact for this is pretty straightforward. So there's lots of components interacting with each other, but with general contact, it's powerful. We're making life easier for you. It's just a matter of a few clicks. You can set up the contact property and then just assign it. And with a couple clicks, you're all set. You can continue to set sub assignments for different friction interactions for other components if you'd like. And that's just a few more clicks again. So here again, we've seen these results already. We're looking at the stress, but we can also take a look at the contact pressure, and we can peel away some of these parts and see how these components are interacting with each other throughout the loading. And then in the next example, we'll talk about general contact as well, but we're going to also talk about this in the context of the explicit solver, which is another great additional capability that you'll have. So in this situation, the contact between the components is pretty easy, but the self-contact is extensive. We're just going to crush the empty aluminum can here with this block, dropping it on it. So you can see, again, it's just a pretty straightforward setup. A few clicks to set up the contact, and we've captured everything, including all the self-contact in this situation. With the explicit solver, this is an impact or a drop test. We can easily run this and capture all the deformation, the plasticity, and here we're taking a look at all the contact. And we'll go ahead and remove the block to take a little better look at this. And you can see the extensive self-contact happening in the deformation of the can. And then we'll go ahead and cut the can in half and take a look again at all the contact that we're seeing. And this is just one of the examples for the explicit solver. I've included a couple more examples as well, some simple models. And so the next one is a impact of a drone propeller, high-speed, short duration event of this propeller impacting this rigid body here, and we're using material damage and element failure, and we're seeing that. Another example of an explicit test here would be the virtual test would be a drop test. So we're running this on a handheld emergency rescue device and just taking a look at some results here when this object is dropped. And finally, of course, explicit results are often used for crash, and a colleague of mine at SolidWorks just put together this fun little example of running a forklift into a post, and this was done with explicit as well. So we do have a few customer testimonies here, a couple that I wanted to share before I leave you with this. So SGA is an Italian customer, and they're able to speed up their vibration damping product development with our simulation solution. They're using Structural Performance Engineer on the cloud to validate these anti-vibration performance of the silent block, in this case of on a connector arm bushing. They provided a pretty nice quote. 3DEXPERIENCE Works gives us a full range of tools that we need to ensure that our products are safe and reliable. Another customer that we have here is in Focus Energy Services, where Pete was able to work on some new bearing designs and save a lot of time and money using the cloud and our platform solution to do this. And his quote, with Smoothly Works, we were able to evaluate a range of geometric and material options, a process that helped us quickly optimize the tapered barrel shape design of the bearings and also decide the best high strength steel for the design. So thanks again for listening.
Thank you, guys. Now imagine if you are trying to order your dinner while at a fine restaurant, and all they gave you was a list of ingredients they had in their kitchen. Not very useful. Instead, a description of what the fully prepared meal will be, preferably with illustrative pictures, would be much better. Similarly, on the software side with 3DEXPERIENCE, each R2021x release contains illustrated details on how your specific industry workflows can be enhanced with the collection of available roles and associated apps, including value-added statements of what is new and improved with respect to user experience and functionality. Now I will show you where you can get the full menu of what is available in each 3DEXPERIENCE platform release. There are a few resources available directly on the platform that provide you with these value, with the value provided in each release. So you can navigate the portfolio directly in 3DEXPERIENCE. There's a What's New community post, and there's a program directory. I'm just going to go into a little bit more detail on each one. So when logged into the 3DEXPERIENCE platform, you can navigate the entire portfolio, selecting the world icon in the upper left. You can see each portfolio. Clicking on each one, you can see the portfolio. You can choose the portfolio. You can choose the industry from among these. That expands more details here. After choosing the industry, you can choose the solution, where you see some information, some text, images, and videos. You click on the individual processes that are within that solution. Again, videos, images, and details of the value added. And then for each process, there's a collection of roles that contribute to that. You choose the role, let's say structural analysis engineer, for example. And this is a list of all the apps that are included in that role. So all the value is clearly stated in this structured manner for you to navigate and find out exactly what you're getting in each release. There's a generic, publicly accessible user community called What's New, where essentially the value added per release per FT is given for each role. So you can similarly navigate. Once you click on the link to this dashboard, you see the works portfolio, the industries portfolio. If you click on the industries one, for example, you see a collection of what's new with new roles or what's new with the enhanced roles in that particular release. So you see here, this is showing it for FT02. You see when you click on, let's say you want to see the enhanced roles, you click on that, and here's all the roles that were enhanced. Then you click on the one that you want to learn more about. You click on that, and you see there's the exact information that I showed you earlier in the presentation, the functional and user experience value delivered for that particular FD, including images, text, and movies. For more details on each improvement, you can go to the program directory for an app-based collection of information. Here you choose the release of interest, top, then the portfolio you see on the left. Then there's arranged different themes like electromagnetics, structures, and then all of the roles will be, when you click on that, you see all of the roles associated with that theme. Then you can pick your role, in this case structural analysis engineer. And then that role, you see all of the apps that are contained within the role. And then when you click on the particular app, you can see all of the enhancements particular to that FD that you've chosen up here at the top, and also all the known issues that are associated with that particular item. So in conclusion, much like using a menu at your favorite restaurant, the R2021x 3D Experience platform provides you with clear, illustrated examples guiding you to apply the latest simulation technology in your daily simulation activities. The value added shown at the app level all the way through your industry-specific workflows helps you go from playing with individual gears to contributing to a well-oiled system of gears working in concert to achieve larger goals.